Hello guys, today we will see the Leetcode problem number 3634, which is minimum removals to balance array. Let's see what the problem says. You are given an integer array nums and an integer k is given to us. Okay, the nums and k is given to us. The array is considered balanced if the value of its maximum element is at most k times the minimum element. Okay, so if the array will be considered as a balance if and only if the maximum element will be greater than or less than, the if its value of its maximum element is at most k times the minimum element, means minimum element multiplied by k should be the maximum element. Okay, so and the maximum element can be less than that also. Okay, so for that we have to delete some of the elements. Okay, you may remove any number of elements from nums without making it empty. Okay, return the minimum number of elements to remove so that the remaining array is balanced. Okay, so we have to remove the minimum number of elements in the array. One is considered as the balance as its maximum and minimum are equal and the condition always holds true. Okay, for the if the array is of size only 1, so this condition will always will be true. Okay, so how we will see 1629, let's see this example 1 6 2 and 9. Okay, in this example we have this array. Now we will sort we will first see that if we delete any of the element, just like the minimum element is this and the maximum is this, so our k value is given as 3. Okay, so the k value will be given as 3, and now the condition is 1 into k value, means 1 into 3, we can say 1 into 3 should be greater than or equal to the maximum value. Max value means we can say 9. Okay, so is it the valid condition now? No, because the 3 into 1 will be 3 and it should not be, so this condition is not satisfying. Okay, so what we have to do now? Now we can remove 9 or we can remove 1 also. Okay, so number of elements we can remove. Okay, but we have to remove minimum number of elements. Okay, minimum number of elements. Now how we will minimize this number of deletions? Okay, number of deleting elements. Okay, so for that we will first sort our array. Okay, now if after deleting it again it is not satisfying the condition, but after deleting one after deleting 6 and 9 both, so we have now the condition is 1 into 3, so it becomes 3 and 2 is the maximum one, so 3 is greater than equal to the maximum element, so this condition is satisfying now. Okay, so now how we will make it, how our approach will be to find out the minimum number of deletions, okay, from the array. So for that we have 6 and 9. Okay, now we will first sort this whole array 6 and 9. Okay, now for this we have k is equal to 3. Okay, then now we will take the left and right pointer. The left will be here only, left, and right will also be here. Okay, just take left at down and right at upper side. Okay, so left is here, left is at the 0th index and right is also at the 0th index. Now we will calculate the left, the maximum element, the left. Okay, up to which it can go. Okay, because the maximum element at least the condition which has given to us, the maximum element is at most k times the minimum element. Okay, that means the maximum element cannot be greater than the k times the minimum element, means the max element should be less than or equal to the minimum element. Okay, minimum element into the k. Okay, so this is the condition which we have to satisfy, that the maximum element should be less than or equal to the minimum into k value. Okay, so for this, if we have to follow this rule, so let's see, for index 0th, if we take this as a this as a minimum element. Okay, if we take this as a minimum element, so what is our limit, means how much we can go? We can go up to k into 3, means 1 k into 3, not the k into 3, k into 1, means 1 means the element which is present on the 0th index. Okay, so it will result it into 1 into 3. Okay, means 3 is the kth value. Okay, so it will result into 3. Okay, so how much long we can go? So right pointer can go up to this 2. Okay, now after this, if we take this as, okay, so the second index as L. Okay, the 1th index as a L. So what's our maximum value? Maximum value will be 2 into 3, means the kth value. Okay, will be 6. So then our R can go up to this point. Okay, after this, if we take 6, okay, 6 as a left. Okay, so our R can go up until 6 into 3, 18. So it can go up to the 9. Okay, or beyond this, if any of the element which is less than the 9 are present there, it can go up to that. Okay, now if you get the approach, okay, if you are getting the what I am trying to say, that this R is firstly here for the 0th index, then here for the second index. Okay, when the left is at 2th index. Okay, just, okay, I can give you the overview now. What is happening, that R is traversing to the right side, because when the left is increasing, the right, means the right boundary, the maximum boundary is also increasing, because left into k we have as the maximum boundary. Okay, maximum boundary up to which we can reach. Okay, so that's why we have that left can go to the right side again and again. Okay, so when left is here, so right can be reached up to that 1th index. When left is at 0th index, right can reach up to the 1th index. After that, when left is at this index, so right can go up to this index, because 2 into 3 we have 6, so it can go up to this index. Okay, after this, when left is at this index, so right can go up to this index, or if there is any 10 is present, so then also it can go, because 6 into 3 we have 18, so it can go up to 11 also, it can. Okay, if there is 19, so it can go up to 18 now. So that's why if this is our left index, so it can go until this 11th index. Okay, 11th index, not, it will be the index which is present on this 11th. Okay, so this R value is increasing, so we will increase our window size whenever our ith will be changing. Okay, or the left pointer will be changing. Okay, so what's our approach is, when we have this left pointer at this, so we will perform a while loop. So the while loop contains the condition which while loop until which the r is less than n, and until the value means the maximum value which we can reach. Okay, the maximum value which we can reach will be the nums of L. Okay, this is the L, nums of L, maximum value up to which we can reach, into nums of L into we have k. Okay, if it is now nums of r, sorry for this, if nums of r, if this is until now less than or equal to the nums of L into k, so until that we will increasing our r. Okay, r plus plus, we will do the r plus plus. Okay, until this condition remains true. Okay, because this is the value which we are looking for, that this can be the maximum value. Okay, means the nums of L into k means this will be the maximum value. So in this way the maximum value for 1 will be 3 into 1, which is 3. So the right can go up to this. Okay, but now when the while loop will run, the right will be present here. Okay, right will be present here, but the right represents that we can take r minus of 1 elements, means we can take this range. Okay, this range is satisfied range. Okay, this range we can take. Okay, and if r is here, so it represent this range is the safe range. Okay, this range, this array of elements is the safest, okay, or the balanced, we can say. Okay, here it is represented as a balanced. Okay, so in this way our approach will be working. So let's see the code. Okay, first in this code we are sorting our array. Okay, and after that okay, we are initializing answer to the n minus of 1, means the maximum it is given that in the note the array of size 1 is considered as a balance as its maximum and minimum are equal. Yes, when the array is of size 1, so its maximum and minimum will be 1 only. Okay, will be that element only, so that's why it will satisfy that condition. Okay, example, we can say if we have 3 in our array. Okay, 3 in our array, so our max will be 3 only, and the mean will be also 3. So our max will be always less than or equal to the 3 into our k, any element. K can be any element, but it will be the positive element. So if we take k as a minimum element as a 1, so again it will satisfy this condition as 3 is less than equal to the 3. Okay, now okay, after this we have left and right pointers. Okay, now for this left and right pointer we are traversing from 0 to n minus of 1, because when there is 3, 4, 7 element. Okay, so the left can go up to this. Okay, after taking left as a 7, so the right will be at the out of the array index. Okay, so that's why we are taking as a n minus of 1. Okay, now L will increment every time. Okay, and when the L is incrementing, so if we have 3, 7 and 4, okay, and our k value is equal to k value can be 2. Okay, k value is 2. Now if we want to traverse this array, if we want to traverse this array. Okay, now we will firstly calculate that our maximum limit. What is our maximum limit? The temp is storing our the maximum limit, max limit we can say. Okay, max limit, and after that we perform the while loop until the r is less than n, means until the r is in the boundary only, and until the temp is greater than equal to the nums of r, means the temp means the maximum limit is greater than equal to the nums of r, means the right boundary, until the right boundary is less or equal to the maximum limit. Okay, means when our when our left is here, okay, when our left is here, then right is also here only. Okay, then what will be our maximum limit? So the maximum limit will be 3 into 2, okay, will be the 6. Okay, so it can go up to the 6, so it can go up to the 6, but now r is satisfied this condition, okay, because 3 is less than equal to the 6. Okay, so now r is here, but if the r is at this index, so it indicates that it is not sorted one. Okay, firstly we have to sort it. Okay, 4 and 7 is there. Okay, now if 3 is less than equal to 6, yes, then r will be go here. Okay, now again the while loop will not stop. Okay, now again it will check for the condition that if 4 is less than equal to the 3 into 2, okay, which is 6. So 4 is less than equal to 6, so that's why r will go here. Okay, now after going here, the condition doesn't satisfy because 3 into 2 is a 6, means 7 is less than equal to 6. This condition doesn't satisfy. Okay, so that's why r will remain here only. Okay, now if r is here, so the satisfied array will be this. Okay, so the satisfied array will be this, so that's why we have to remove the elements which are left to the left pointer, and the element considering the r and the right to the right pointer by considering the rth pointer also. Okay, so now this work is done by this. Okay, so here the n minus of r is representing the right to the rth pointer, means this part. Okay, this part is considered as the right to the right pointer, and this L is indicating the left to the left pointer. Okay, left to the left pointer, because L is the zeroth based indexing. Okay, we are taking here the zeroth based indexing, so that's why. Okay, and we will minimize it at every iteration, and now we can get answer, the correct answer for every index. We can minimize it and we will get the correct answer. And if you have any of the doubt, please make sure to comment down below, and I will see you in the next video. Thank you.